So let's talk about the weather. I don't mean that in a small talk way. I mean, let's really talk about what causes the weather that we experience. And the main things that cause those are pressures, air pressures, and fronts. So, air pressure. What exactly is that? We've learned that we measure air pressure with a barometer. We know that it can rise and fall, and that means different things for the weather. But what is it really? So, first off, an air mass or an air system, they're the same thing, those are interchangeable. There are large masses of air that have similar qualities. So they have the same temperature, they have the same humidity, and they have the same air pressure. And there are two types of air systems or air masses, which are high pressure and low pressure air masses or air systems. Just like we learned with our barometer, right? Telling high pressure from low pressure. That comes from this. What exactly is air pressure? Really quick before we get into the two systems. Most weather that we have comes or is caused by air pressure. And so even though you can't see it or feel it, all the air around us has weight and is pushing down on us because it has weight. Like gravity is also pulling the air down, right? Technically on top of us, even though we can't feel it. The reason we don't get crushed and the reason we can't feel the air pushing down on us is because we have air inside us, right? I mean, we breathe it all the time, but we also have air other than just in our lungs that is also pushing out as at the same rate or the same intensity as the air pressure that's pushing down on us or pushing in, so it balances out. So we're all okay. But because of these air pressures and how they might differ, high or low, will bring us weather and different types of it. So let's talk about which one is which. Which one brings what kind of weather? So, as we've said, there are two pressure systems. We got a high pressure system and a low pressure system. I'm going to start with the high pressure system. So our high pressure systems is when the air pressure is greater than the pressure around it. So there's more air pressure. It's high. I mean, high and greater, that should make sense. It goes together, right? So a high pressure system has more air pressure than the rest of the air around it, okay? And typically high pressure air pushes low pressure around. It's a bully. High pressure likes to push low pressure around, and low pressure can't do as much with that. And so that's what creates wind. So when you experience wind, it's because some high pressure air mass is pushing around low pressure air mass. And that's when we have wind. It does come from or can be caused by other things, but a lot of times it's this. The air pressure is kind of pushing each other back and forth. High pressure systems are associated with cool, dry air and happy weather. So this brings us sunny weather. The reason we say happy weather is because happy is an H, high is an H. They go together, high and happy. And obviously happy weather would be sunny, maybe some clouds, but nice clouds, right? So like cumulus clouds that make us want to go outside, okay? The H's that you see as my bullets, that is what represents a high pressure system on a weather map. So when you see, if you have ever watched the weather on your news channel, or you get it on your phone and you see the actual weather map, if you see a big capital blue H, that means there's a high pressure system there. So that place is getting happy weather, cool air, and it has more air pressure than surrounding areas. Low pressure, on the other hand, has lower air pressure than the air around it. Again, that seems like obvious, right? A low pressure system is going to have lower air pressure. But what does that mean? Low pressure air is usually warmer and it carries more water vapor, okay? So remember how high pressure air pushes low pressure air around, okay? Because the low pressure air has that water in it, okay? And the high pressure air pushes it around and pushes it up because heat rises, right? So warmer air will rise, okay? That water vapor will go up with it and form into clouds that we know, right? Water vapor turns into clouds and eventually will bring rain because as the clouds get bigger, we talked about that, right? Eventually it will rain. So with low pressure systems, unfortunately, we associate yucky weather, whether that's rainy, snowy, or cloudy. Obviously, nice clouds aren't that bad, but this kind of cloudy would be like stratus clouds or cumulonimbus clouds that bring rain and snow and just kind of like bleh. Like you don't want to go outside with a low pressure system because it's kind of gross. Things are muddy and whatnot, or it's cold if it's snow. So low pressure air, because it's warmer and has that water vapor, it tends to create more storms. And again, as far as its symbol, you can see if you see a capital red L on a weather map, that's telling you that there's a low pressure system in that area. So they would be expecting not great weather, probably rain, or if it's below 32 degrees Fahrenheit or 0 Celsius, right? So if it's below 0 degrees Celsius, then they'd be getting snow, okay? And we reviewed that when we talked about precipitation and all that good stuff. All right, so the other thing that causes a lot of the weather that we experience are fronts. So a front is just the boundary where two air masses meet, okay? So that's talking about like our high pressure air and our low pressure air, where those two air masses meet, that is a front. It's like a line, the battle line, right? Because the high pressure and the low pressure air push each other around, and the high pressure air usually wins. But that's the battle line. The front is the battle line where they meet, okay? And there are two types of fronts. We have a cold front and we have a warm front. So let's see what those entail. So a cold front, let's start with that. A cold front, logically, okay, happens when cold air goes underneath warm air. So the cold air in this case is winning. And remember we said heat rises. So the cold air is not going to go over top the warm air. It's going to push underneath it and move the warm air out of the way. Kind of like, this is my turn now, goodbye, and slide underneath the warm air. What that means for the weather is because it's pushing, again, that warmer air, because this is cold air. So because it's pushing that warm air up, which has water vapor, right? We just talked about that with like low pressure. It's going to form cumulonimbus clouds because that water vapor is going to condense into a cloud and eventually get to be a really big angry cloud, right? Cumulonimbus. So that's going to lead to storms. So when we have a cold front, you're going to get rain. Or if it's below 0 degrees Celsius, you'd get snow. But you're going to definitely get precipitation with a cold front because it pushed that warm air up out of the way and made cumulonimbus clouds, okay? And obviously from the name, not only does a cold front deal with cold air, it's also going to make the temperature cold, okay? So after a cold front passes over an area, there will be a drop in the temperature of that area. So it won't happen right where the front is. It's technically like behind the front. So after that front line goes past your city, then your city has colder temperatures. And we'll look into that when we look at some weather maps and see if we can determine what weather certain places will be having, okay? So let's see some pictures of what I'm talking about so we can understand a little more. So here's an example image of a cold front. You can see the blue air there, that's representing the cold air coming in, okay, pushing the warm air up and out, which is it's not like red or anything, it's just normal colored air. And you can see those cumulonimbus clouds there forming right along that front line. It's blue there, and there's heavy precipitation. Here's just another version of that, same thing, blue cold air. This one, the warm air is red, so you can see it. And right along that front line, right where they're meeting, are all those cumulonimbus clouds and that rain, okay? Now, on a weather map, it is important to know what a cold front looks like. So when you see this symbol, it's a line with these triangles on it. That tells you there's a cold front. That's what a cold front looks like on a weather map. Conveniently, it's blue, right? We think blue and cold. But also, those triangles, think of them as icicles, right? Because it's a cold front. So it comes with icicles. And so those icicles or triangles point in the direction that that cold front is moving. And as you can see in this picture about the temperatures, right? The colder temperatures are behind the line or after the front passes that area. It brings the colder temperatures with it. It's not necessarily the cold temperatures right on that line. As you can see, it brings it with it, so they follow right after, okay? And here's just a little animation rather than just another still picture, so you can kind of see how it's moving and how those clouds are forming, because you can see that warm air being pushed up and those cumulonimbus clouds forming and the rain falling right there along that blue triangled line. That means a cold front. All right, so now we have the opposite, a warm front, okay? So again, logically kind of like the cold front, a warm front happens when warm air pushes over cold air mass. So in this case, our warm air is winning. Now heat still rises, so the warm air is going to go over top of the cold air, but this time it's choosing to do that. That's why I say it's winning. Whereas in the cold front, right, the cold front or the cold air mass is kind of like, my turn, and they push the warm air out of the way. But here our warm air chooses to push over the cold air, I guess kind of like a leapfrog, right? So it's going to push up over that cold air. So what comes with that? So warm air is less dense, which is why it goes over top. Like I said, heat rises, so it can't push that cold air away, and that brings cirrus clouds, okay? And we talked about cirrus clouds. At the time you see cirrus clouds, we have good weather, it's nice, but they tell you that some light precipitation is coming. Usually that's light rain, but again, if it's below 0 degrees Celsius, you can get snow, right? Because it's just frozen rain, really. So warm fronts will bring a little bit of light precipitation, but nothing like thunderstorms or anything with a cold front. The cold front was the cumulonimbus clouds and lots of rain and thunderstorms, okay? Warm front is less intense. It has those cirrus clouds to tell you it's coming, and a little bit of rain to follow a few days later. And again, credit to its name, not only does a warm air mass or a warm front have warm air mass, it also brings the temperature up, makes it warmer. The temperature rises. Again, this is after that warm front has passed an area. It brings those temperatures with it. So it's not right on the front line, but it's right behind it. It's being brought with it. Those temperatures will go up. So some images for a warm front, how it looks different than a cold front. So here you can see our warm front. It is just kind of rising right up over like a ramp, right up over that cold air. You can see those clouds forming, and right there at the edge, the farthest ways over, there are cirrus clouds, right? So over there, it's some nice weather, but you can see right closer to the front line, right, there is some, what they say, moderate precipitation or light rain, right? So if there's a city it's approaching, right? Let's say Richmond, since that's near us. If the warm front is approaching Richmond, on Tuesday, we have cirrus clouds and good weather, okay? And then by Thursday, we have rain, right? Because the warm front has moved closer to us and brought that rain, but will also bring us our warmer temperatures. Again, here's just the other picture where you have the red warm air coming up like a ramp over the cool air and making those lighter clouds and a little bit of rain. So on a weather map, our warm front is represented, thankfully, with red, okay, so because it's warm. It is a line, but it has little half circles, okay? And I say those semicircles, they're like the sun. They're like rising suns, right? So the sun is hot or warm, just like the icicles or triangles are cold for a cold front. So our little half circles are rising suns. There are little suns for our warm front. And you can see there again, the warmer temperatures are following that front line. They're not right on top of it. So after that warm front passes, you'll have warmer temperatures in that area. And lastly, here is a little animation, just like I did for the last one, where you can kind of see how that air is rising up over, creating those clouds and having a little bit of rain. Okay, so this is where we get most of our weather. It's either from high and low pressure air pushing each other around, and or it's from warm fronts and cold fronts as they happen to, as those air masses are moving, as they happen to move and interact with each other, we get different types of weather, okay? So next we're going to look at how to read a weather map and predict some weather.